Today we're going to be exploring this 4-in-1 sensor. As a smart home enthusiast or tinkerer, you've probably got temperature sensors around your home, whether it's pre-built Zigbee ones or perhaps DIY ones that you've built yourself. You might even have humidity sensors and use them to turn on the extractor fan in your bathroom when the humidity gets too high, but many people don't consider monitoring the quality of the air that they're breathing in, particularly in winter when you might be cleaning or painting with the windows closed. In this video, we're going to integrate an air quality sensor into your smart home using ESPHome. As well as measuring air quality, this sensor can take temperature and humidity readings too. It can also take extremely accurate air pressure readings, which is what the old-fashioned barometers used to use to try and predict the weather using air pressure, although I wouldn't recommend using this device for a weather forecast. When we're talking about air quality, we're specifically talking about VOC values, which can detect potentially harmful elements in the air, such as acetone, carbon monoxide, and many more. After the sensor has performed its magic, we can then end up with a nice and easy to understand description of whether the air quality is good or not. This chart shows you the 7 different levels of pollution and suggested actions to be taken. We've got excellent, good, lightly polluted, moderately polluted, heavily polluted, severely polluted, and extremely polluted. Thankfully, as you can see in this room, the air quality is showing as excellent. I've got an ESP8266 device here, which I've wired up to the sensor. I've used a breadboard for now, just so that you can see all of the connections, but if you wanted to put this sensor in an enclosure, then you could use some DuPont wires instead. You will want to place the ESP device a few centimetres away from the sensor itself, so that the heat of the ESP doesn't impact the temperature reading on the sensor. Having said that, it's only accurate within a degree anyway, so you probably don't want to use it for something like controlling your heating. The wiring is very straightforward. You connect the 3.3 volt pin from the ESP to the VCC on the sensor, and then the ground on the ESP to the ground on the sensor. The other 2 wires are for communication over I²C. I've connected the SCL pin on the sensor to D1 on the ESP8266 and the SDA pin to D2. It doesn't have to be these pins, but it's common practice. Unlike other pins, the state of these pins don't cause any issues during the boot process, which makes them great for connecting sensors to. I've already done a beginner's guide to ESPHome, so if you don't know how to install ESPHome onto an ESP device, then check this video out. I also did a quick install section on my Bluetooth proxy video at around 6 minutes 30 seconds, so you could follow this instead and just paste in the YAML code from the link in the description of this video. You might be thinking, what is the other sensor below? It's mainly there because I wanted to demonstrate that the I²C protocol is a bus, which means that you can connect multiple devices to the same pins on the microcontroller, which is a great way of saving available pins and can sometimes make the wiring less messy as well. Stick around until later in the video if you want to find out what the other sensor is. If you don't use HomeAssistant, then you can run ESPHome standalone. Of course, you want to send the sensor data somewhere, so I recommend either using the MQTT or HTTP components to send the data to your smart sensor platform of choice. If you do use HomeAssistant, which I highly recommend, then you should be pretty much done. Here you can see that the ESP device is showing us online, and if I go to the integration section, you can see all of the sensor data showing. The main ones you'll probably be interested in are the humidity, IAQ classification, pressure and temperature. The air quality number might also be of interest because it will give you an idea of how far inside the classification you are. Excellent goes up to 50, so as you can see here, the air quality within this room is well within that boundary. Now of course I've given away what the other sensor is. It's a distance sensor, which can measure distances between about 4 centimeters and 1 meter, and up to 2 meters in long range mode. But before we jump into looking at this sensor, let's take a look at the YAML. We have the standard configuration bits first that you will need for most ESPHome devices. And then we have the I²C component where you can tell it what pins you're using. There are also other settings available here, such as setting the frequency that the bus runs at. Some devices may need you to run it at a minimum required frequency. The higher the frequency, the shorter the I²C wires need to be before you start getting communication issues. The next bit is a template sensor to take the raw IAQ value and convert it into human readable ranges. And after that, this is where we set up the sensor itself. You can just copy my code that's taken from the ESPHome documentation. The only things that you need to change are the names, as these are what the entities will be called in HomeAssistant, and possibly the update interval if you want more or less frequent updates to be sent. Now quickly on to the second sensor. It's called the VL53LOX time of flight sensor, and as mentioned before, it can measure distances up to around about 2 meters. I would say it's an indoor sensor really, because it's got very delicate sensors on it. But as long as you keep it fairly protected, then it should be fine. I've had a play around with this sensor, and I can see it being quite useful for detecting when people walk past the sensor. But it can be off by up to around about 10% in distance, so it might not be useful for some situations. But I do plan on doing more videos on distance sensors and other I²C devices, so stay tuned for that. And let me know in the comments if you've come across any cheap, interesting sensors that you think I should check out. And remember to look at the links in the description for an example YAML file, some ESPHome documentation, and the datasheet of the sensor. Well, that's it for today, so please consider subscribing if you haven't already, and liking the video if you enjoyed it. And leave a comment down below if you've used any of these sensors before. So thanks, until next time.